Welcome to Chapter 7. Now we're going to be talking about chemical quantities and reactions. So it's really cool because exercise physiologists worked with athletes as well as with patients who've been diagnosed with diabetes, heart disease, pulmonary disease, and other chronic disabilities or diseases. And so we're going to learn how different calculations can help with their job in treating these patients. So the first thing we get to talk about is what is a mole. So a mole is the counting term that states a specific number of items. This term would be dozen, case, gross, and ream. These are all used to count the number of items present. For instance, 24 cans equals 1 case of pop. 144 pencils equals 1 gross. 500 sheets of paper equals 1 ream, and 12 eggs equals 1 dozen. So these are all known things, and so we're going to use calculations and learn how to use Avogadro's number to determine the number of particles in a given number of moles. So what is Avogadro's number? Well, we hear a lot about it, but do we really know what it is and how to use it? Well, we will after this video. So small particles such as atoms, molecules, and ions, they're used and they're counted using the mole and a unit called Avogadro's number that contains 6.02 times 10 to the 23 items. So again, 1 mole equals 6.02 times 10 to the 23 items. And if you write out Avogadro's number, you get this really long number with 23 placeholders, right? And Avogadro's number is named for an Italian physicist, Amedeo Avogadro. And so we'll use this a lot in our calculations today. So 1 mole of an element is 6.02 times 10 to the 23 atoms of that element. 1 mole of carbon equals 6.02 times 10 to the 23 atoms of carbon, the same with sodium. So what we're going to be able to do is be able to look at a formula and convert these particles to the specific moles of that unit. So here is your table of particles in 1 mole of samples. So 1 mole of aluminum is 6.02 times 10 to the 23 atoms of aluminum. Same with sulfur, atoms of sulfur. 1 mole of water is 6.02 times 10 to the 23 molecules of water. Vitamin C, since it's a combination, would be molecules of vitamin C. 1 mole of sodium chloride would be 10 times 0.02 times 10 to the 23 formula units for sodium chloride. So when we are looking at Avogadro's number, 6.02 times 10 to the 23 can be written as an equality or as 2 conversion factors. So an example is 1 mole equals 6.02 times 10 to the 23rd, and you can write that either with the mole on the top or the mole on the bottom. They are the same thing. So depending on how we're setting up our equation, we're going to need to have those either on the top or the bottom. So here's your handy dandy little guide of calculating the atoms or molecules in a substance. So step 1 is to state the given and needed quantities. Step 2 is to write a plan to convert the moles or atoms to atoms or molecules. Step 3 would be to use Avogadro's number to write the conversion factors. And step 4 would be to set up the problem to calculate the number of particles. So for instance, again, now we're going to use this in converting moles to a molecule. So Avogadro's number is used to convert moles of a substance to particles. So how many CO2 or carbon dioxide molecules are in 0.5 or half a mole of carbon dioxide? So what are we going to do? We're going to set it up and we're going to state the needed and given quantities. So what are we given? 0.5 moles of CO2. And what do we need? The molecules of CO2. So we're going to write a plan to convert the moles or atoms into those molecules. So we're going to have the moles of CO2, and then we're going to use Avogadro's number to make it and convert it into molecules of CO2. So let's set it up. So 1 mole is 6.02 times 10 to the 23. So remember that this is the same. If we have it on the top versus the bottom, we just have to figure out which one we need to do so that we can cancel out the units. So let's set it up. We have 0.5 moles of CO2, so we're going to want to pick the one that has moles on the bottom so that those two can cancel out. And when we take 0.5 times 6.02 times 10 to the 23 third power, we get 3.01 times 10 to the 23 molecules of carbon dioxide. So let's practice. What is the number of atoms in 2.0 moles of aluminum? And here's some answers. Pause me and let's come back. So what we're going to do is analyze the problem. We were given 2 moles of aluminum and we need atoms of aluminum. So let's write out the problem to figure out the plan to convert the moles to atoms or molecules. So we have the moles and we need to convert it to atoms. So what are we going to do? Again, we know that 1 mole is 6.02 times 10 to the 23rd, and we need to pick which equation we want to use. So since we have moles on the bottom, or we have moles on the top, we're going to want to keep the moles on the bottom on the other side so that they cancel each other out. So we have 2 moles of aluminum times 10, times 6.02 times 10 to the 23rd atoms of aluminum. Those moles cross out, so 2 times 6.02 times 10 to the 23rd gives us 1.2 times 10 to the 24th. Okay, so see that we increased a power of 10 because that would end up giving us 6 times 2 is 12, and then we shifted over that 1 decimal point. So that gives us to 10 to the 24th. So again, I'm sorry, the answer would be C. So let's do another one. What is the number of moles of S in 1.8 times 10 to the 24 atoms of S? Pause me and let's come back. So again, we're going to analyze what was given and what was needed, and then figure out that we're going to convert moles to atoms or molecules. Okay, so we have atoms, and we're going to use Avogadro number to go to moles. So again, let's set this up, figuring out which one we want on the top. So what we're going to end up doing is we're going to have 1.8 times 10 to the 24th atoms of sulfur, and then that would be the Avogadro's number on the bottom, and then those would cancel out, and that would be 1 mole. So you'd end up having 1.8 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23, and that ends up giving you 3 moles of sulfur atoms. So the answer is B.